This demonstration is about solving the linear system of equations ax equals b, where we have the simple two lines where one is determined by the equation 2x plus y equals 0 and x minus 2y equals minus 2. So our objective is to attempt the Python program, and here we go. Okay, so I have a file, Python program. So the matrix is 2 by 2 system, ax equals b, 2x plus y equals 2, and x minus 2y equals minus 2. Uh, since Python index for arrays starts from 0, so the matrix form of this system would be written as A00, A01, so then A10 and A11. Similarly, B is the column vector with elements B0, B1, and the x vector is x0, x1. So where this x1 is equal to our x in the system of equations, and x1 is equal to y. So we have to work with the uh, matrix notation so that we can learn how to program it. So I start with the library import. So I write import numpy as np, and well, since I'm not interested in showing a graph here, just the algorithm, so only this library is sufficient. The next is to create an array for a. So here we go. So I write a equals numpy array, and it's going to be a 2 by 2 matrix. So I write the numbers 2, 1 for the first row, and then I will write 1 and minus 2 for second row, and it will be here. I can see the creation of array just by saying write a. Okay, so 2 1 1 minus 2, 2 1 1 minus 2, and for b vector we have 2 and minus 2. So a separate part just for showing. So b equals numpy dot array, and I'm going to say 2 and minus 2, and we can see that it has been rightfully created. Okay, then the next one, I would say x old. Okay, let me write x old equals numpy array, and I store here the initial guess 0 0. So we may start with any other guess, initial guess. The new one, I will say, okay, for the time being, it is also equals 0 0. This is the initialization for array creation. Array creation. So this has been successful. And now for first iteration, we can say from the first equation, so it is 2 minus y divided by 2. So a new value of x should be computed by taking all the terms on the right hand side and dividing by the coefficient of x. In our case, that will be the coefficient a00. So in matrix notation, I write that the x new value will be x new value of 0 will be equal to, from my equation, so I can write in matrix notation, it will be from the first equation b0 minus a 0 1 times the x old of x1 and divided by a 0 0. So this is the transformation of this system in matrix form, and I have utilized the first equation to compute the new value of x0, and then I will say x new of 1, that will be equal to, it will come from the second equation. So the second equation in matrix notation, it has the right hand side equals b1, so b1, and from here I am interested in getting this value. So we can write in matrix notation, I can write simply it's b1 minus a10 times x old of 0 divided by a11. So it can be easily noted that a new value of x0 has been computed by getting the old value of x1, and the x new of 1 is computed by getting the value of x old of 0. So this should be noted. And okay, let me confirm the parenthesis, balance of parentheses. Okay, well, the parentheses should be balanced over here. So, and I add a comment here that it is from first equation. For the time being, we are working with the explicit notation. And let's see whether, okay. The first array is A00, A01. So A00, A01, and in second equation, the coefficients are A10 and A11. So A10 and A11. So let's see. Okay, so this has been computed. Now the next thing is to write the new values of XU. Let's see. Okay, so they have been updated 1 1. Right. The next step in the algorithm is to compute the error. So error, we compute numpy. We compute the error as numpy dot linear algebra dot norm function, and I'm interested to compute the norm of the 2 x new minus x old, and this is like the distance formula. So like the distance formula, the norm function is like the distance formula. The old point and the new point. We started with the point 0 0 as the initial approximation 0 0, and we got a new value in x new. So let's see the error calculation. Okay, so it is 1.414. So we can now compute the next uh, iteration. So for that very purpose, we can write x old for all values equal to x new for all values. Well, these parentheses should be consistent with the Python structure. So there is no error. Let me now check the x old value. whether it has been updated or not. X old has been updated since the values of X new computed from iteration has now been set to the old guess. So this step in algorithm is known as update the initial approximation. So these steps will be repeated from this point because it's the computation of X new and then the error calculation. And when the error is going to converge, we will stop. So this is the procedure. Uh, right after the initializations, we can compute the value and we perform the error calculation, and that's it. So from here onwards, let me write a relatively sophisticated code. So I write again. I will set say x old equals okay x old of 0 equals 0 and x old of 1 it's again 0. And now I'm going to write the in the algorithmic form. So I have to first set a tolerance level. So I say it is say 1 exponential minus 3. I say number of iterations. So for the time being, say okay, five iterations. So I write for I in range number of iterations, and I would like to compute the x old and x new value from this from these expressions. So explicit expressions, right? And the next step of algorithm. So this is the step compute the improved values. The next step is to compute the error, and the error is like this. So just after the same calculation, so error has been computed, and the next step is to update the values. So we set the x old value as x new values. Right. So after 5 iterations, so here there must be the end of loop, and in Python there is no need to write anything. So let's see the answer after 5 iterations. So no error has been returned. So if I see the value of x new, so the value is 0, 1. So let's improve the iterations. For example, say 20 120 20 iterations. And now let me write a check over here. After the computation of errors, after the computation of error, I check if error, if error is greater than the tolerance level, then if error is greater than tolerance level, then there is need to perform a new iteration, and else there is no need to perform further iterations. So break the loop, and that's the end of if statement. End of if statement. So let's see how many iterations have been performed by the computer. Okay, so we have got a green signal that this has been computed, and now see the x new value 0, 1. X new value is 0, 1, and let's see how many iterations have been performed. So I see the I value. So I value is two iterations have been performed, and the value of error is error or E double R. Okay, the true variable E double R. So error value has been set to 0. I have figured out that the calculations were performed in the integer mode. So therefore, there was an update was required, that when we define the arrays. So for example, x old equals. So we have to say that this array and the values must be considered as float to support the real point or fraction floating point operations. So with this one, we have the tolerance level 10 to the power minus 3. So during the diagnosis, I entered and checked the values of x new and then printed that one with the number of iterations, and the rest is the same. So if we now see the error bound, so our calculations will keep on performing with the proper real mode, and we finally get to something zero point 0.4 and 1.2. And to be sure about, we can increase the calculation 10 to the power minus 6 tolerance level. So we will find that such higher precision is found in the 19th iteration. So if I again remove this one, so we will see that the calculations will be performed in the integer mode, and only few iterations will be performed, and the points are only written due to this F format, this F floating point format. So that was the error. So in our calculations, we have to consider the floating point operation. Right. So before that, before this one, the algorithm only contains the statement of the definition of matrix A and vector B, and the rest is the Jacobi method. That is the way Jacobi method works out. We have written explicit equations for that. For a 3 by 3 system, explicitly we have to write 3 equations, and for so it seems when we attempt the higher order matrices, so this strategy, this explicit strategy, won't be very won't be recommended, and will be tedious. So we learn the way to write this equation for n number of equations. So that requires a bit of careful program. So once again, if I run this program that we built explicitly, so from 0, 0, the initial approximation, x old, from this initial approximation, we compute a new value by Jacobi method, keeping the old values on the right hand side and getting a new value on the left hand side. The error calculation, and if the error is greater than the tolerance level, so we update the initial approximation, and else we stop the number of iterations. So we have the iteration numbers printed. So if I set it to -4, so we will be able to see the answer has converged in the 14th iteration. So this is the programming of Jacobi method.